Hey there, this is Seth Warris from Channel 9 coming to you live from NDC Oslo in the beautiful country of Norway. This is my first time in Norway. It's beautiful here. You work here, right?
Yeah, I live and work in Norway.
Fantastic. Well, why don't you introduce yourself, tell us who you are and what you do.
I'm Natalia An and I work as a senior consultant. Right now I work with data science. I love data science.
Yeah.
And right now I'm at NDC Oslo and this is by far my favorite conference.
Yes, it's actually really cool. Hopefully we can show you a little bit later. We'll try to get some footage of we're in a stadium and there's like tons of rooms over here. We have a room all the way up there that you can see all of the sessions. It's pretty cool. But you're in data science, right?
Yes.
So tell me a little bit about, because I love data science. I come at it from like a academic perspective. I know the algorithms, but I don't actually do anything real with data science. Like, I don't have real experience with real data. Tell us a little bit about how you got into data science.
Well, actually, I got into data science like around 1.5 2 years ago, and I used to be a developer. And I always was interested because data science is heavy mathematics, and mathematics is my love of life.
Me too.
But it's not well paid in Russia, where I'm from. So I choose the field which is closest, which is software engineering. And I took an education. And then when I got a chance to join data science, I was like, yeah, finally.
Yeah.
So I just grabbed it and jumped on it. And I'm working as a consultant, and that gives me the benefit of working with real solutions for many companies. So we don't work with just one company, we have a lot of customers, and we implement data science or machine learning projects for different customers. And that's what real life feeling, not an academical stuff.
Right.
That's what I love about it.
So tell me a little bit about, like, if someone wanted to get into data science, what is some advice you have? What are some steps that you have to go through? Because you mentioned you love math, but do you have to love math in order to do data science? What do you suggest?
I think you should love math, because when you start entering data science or machine learning, it's a bit different, but in this case it's same. You need to be not intimidated by the formulas when you see them, and you need to understand them, because that's how it works. And if you don't understand how it works, how can you apply it?
Right.
So look the formulas, don't be afraid of differentiation and such things, and then you're cool. And I think also important is to have like a hunter instinct, because when I'm chasing the model, when I try to improve the model to predict data the best possible way, it's like a hunting instinct. So it's like, it's almost, I'm gonna get it, and you need to keep this feeling, hunter instinct. So that's important.
I'm more of a, like, I really love the whole algorithmic perspective, but most of data science work in the real world is working with data. Can you talk a little bit about your perspective of what kind of work you need to do with data in order to make these things work?
Yeah, well, that's the first thing distinguish between machine learning and data science, because in machine learning, you get the data and you just have to kind of map it, model it. When you work as a data scientist, you start with data. You need to maybe work on integrations. You definitely need to clean up the data, but that I also do for machine learning.
Sure.
So you have to understand the data, analyze the data, see how it hangs together. Does it make sense? Sometimes you get data which is very sparse.
Sure.
There's not so much information. Then you come back to business and say, do you have another data? Maybe it's better data. So sometimes we run a pilot project for customers just to pin the problems they have, because they don't know what they have. They have a lot of, or they think they have a lot, and then you come in and it's like, okay guys, actually you don't have much and you need to do this and that, so we can actually come in and make a machine learning solution for you.
Right.
So that's work with data. And my actually experience when I started was, I was thinking, yeah, I'm gonna do this all cool modeling, and then I spent like 80 to 90% of my time on actually cleaning and looking at the data. So the cool modeling part is not that big.
No, it's a little bit of time.
Yeah, but when you look at the data, you kind of start feeling it, breathing it. You can sleep on data. Once I got my idea having a morning shower, I was like, hey, I need to do that, because I have like my world become with data impacted.
Sure.
And then of course, you have to deploy your solution, because your solution doesn't exist in abstract vacuum.
Sure.
It should be integrated in a business line. You have to understand how business work. You have to help them and not make their life more complicated, but easier.
So let's talk a little bit about the process you go through when you have a data science problem. What does a data science problem look like at the beginning? And then we'll get into the process of how you work. So at the beginning, how do you know you have a data science problem?
Well, as we are consultants, we have a luxury of coming into business when they already know what kind of problem they have.
Sure.
Or, okay, sometimes we come in and they say, okay, we have a data, we know there is machine learning and data science, what can we do? Then we have a look and it's like, okay, what are your daily business, what are your problems, how can we help you. So first, when you do a data science project, you need to find a question.
Okay.
Then you find the question, and of course, first, if you already have a question, you look at the data, okay, can you answer the question having this data which you have?
Okay.
And if you have enough data and you have clear enough question, then you start working on analysis, building the model, and actually implementing the answer.
So what do those questions look like? So I know when we talk about data science, I've heard a lot, you need to start with a really sharp question. What do those questions look like? Can you give me examples of questions?
Yeah, example which is very common for is like, why do my customers quit?
Okay.
Can I predict what my customer will quit? What can I do to keep them? Another example, sending an advertisement. What makes people click on the advertisement?
I see.
Who are my audience? Very common question. Who are my customers?
Okay.
This is very common. And you do clustering and you do analysis and then you present, and sometimes, quite often business goes like, oh, we didn't know that.
Right.
So that's the question.
And I like the idea of starting, because I've heard very many times a lot of people are like, hey, we'll just use machine learning.
Yeah.
What does that even mean? Like, you need to start with a really good question.
Yeah.
So once you have a good question that you want to answer, like for example, why are my customers leaving the shopping cart empty, which is a very specific question. What kind of data do you look at in order to answer that question? And then how do you clean it? How do you know if you have the right data? You see what I'm saying? I'm asking, how do you know that the data is there that you need?
Well, first you ask customers, what do you have?
Right.
And they give you all they have. It's usually, it can be too much or it can be nothing. And then you start analyzing data. You do like, you just see what you've got and how is it hanging together. Is there any kind of patterns in the data? Because data science is finding patterns.
Sure.
And you cannot see the pattern with your human eye. While you do some modeling, the primary modeling, testing modeling, you're actually testing your data for patterns. Okay, is there something here? Is there something here? And then you feel it, and the more you look at it, the more you get the gut feelings of how actually it hangs together. So I don't know if it answers your questions. Like look at your data will speak to you.
There's always this sense, and I've spoken to a lot of data scientists that do this in practice. There's like this horse sense you have. I don't know what it is, but you look at data and you get a sense. How long does it take to develop that sense when you know that, oh, this particular feature is not going to work, or this feature is highly correlated with this feature, or this feature has a little bit of the answer in it, so it's going to overabundantly inform my model? How do you get a sense for
how to develop gut feeling?
Yeah.
I don't know. Just work on it. It's really when your data become part of your world, when you see the world through the data. I started data science and now I see patterns everywhere.
Sure.
It's something you cannot stop. And I think I started seeing patterns. It doesn't sound good. I started seeing patterns like after maybe 7-8 months of working, because my brain entered it with special condition, I guess.
Sure. And so once you start to see the patterns, there's this other aspect of data where you have to clean it. What does that mean to clean data for you?
Well, you see the data and it's like, okay, you do analysis of the features, you do like how they correlate, and it's like, okay, this here makes no sense. Or you just see, okay, this here sounds like a feature because you have to understand the business, you talk to them, and you think, okay, this should be important, but it's empty. The field is like, maybe you have like 1% of field is entered any data and the rest is empty. And you ask them, is it because it's empty or is it because you pulled data the wrong way? Because the luxury of having the raw source data is almost never.
I see.
You enter and they give you some extraction first, and then you kind of get access to the raw data after you've proven that you actually have something.
I see.
So, you need to understand the business as well, the domain, because only then you can map the data to the world. If you don't understand the domain, just numbers is numbers, and then it's difficult to see the pattern. Understanding is important.
Can you speak a little bit to the process of feature selection? When you're making a predictive model, for example, is this person going to leave the cart? How do you know which features to use? And then how do you get a sense for future problems, what you should look at in order to get features that will actually be relevant?
I think it's important when you start a blank sheet. You don't have any ideas, don't have any opinions, because that can shadow you out from the real solution.
Sure.
So I always start with blank sheet. And then correlations, I see the correlations at the data. I do like a lot of graphics just to see what data talks to me. And there are mathematical modeling for feature selection. So if I don't know the domain, if I don't know the data, or pretend I don't. Actually, first I pretend I don't. Then I do some modeling, so model tell me which feature is important.
What kind of modeling are you doing? Like,
well, there are techniques for feature selections, which just basically saying you, okay, this one is important, this is not important. You can have different models. All of them can indicate which features are important.
I see.
So starting from linear regression, which is the most simple, it will tell you which features are important and
just
which are not.
by the coefficient of
yeah,
the weights.
by the coefficients, and you can start with withdrawing. Like if you go to kind of put all in and then you start withdrawing. This is one technique, and you withdraw the least important, and then you are left with the most important features. Or you can start like with something and add more and see how the model improves.
I see.
So it's actually all scientific, the feature analysis. But then it's also interesting because when I kind of reduce the feature selection and I see something which I feel is important, then I come back to business and say, okay, I think this and this and this is important. And it's actually funny to validate it against what business thinks about it.
Yeah.
And then you come back and redo the stuff. And then iterate again and iterate again. And you gain more and more, and then sometimes business say, yeah, but you know, this actually is not what we think it is, but it's something else. It's like, okay, then I need to rethink the whole concept.
Sure. So it's interesting that you talk about modeling in terms of the model to do prediction and the modeling to do exploration. So are you doing modeling for exploration and for prediction? Why don't you speak to that a little bit?
Well, you always do the exploration first.
Right.
Because otherwise you don't know what you have.
So are you doing machine learning models just for exploration?
Yes.
Okay, because you mentioned
and we have
linear
also
regression.
projects. Yeah, we have also projects which are just exploration. So for example, customers come in and say, our customers say, we want to know who our customers are, and we have this data. And we're like, okay, all in. And we start analyzing, see the patterns, cluster the data, and predict the behavior of customers. Because in their case, in the case I worked on, it was find a pattern in customers' groups, and we don't know what the groups are, but they should behave the same.
Sure.
So that was just exploration was the project. Sometimes you need exploration as a first phase, and then you do prediction later on.
I see. So we spoke a little bit about data cleaning, getting a sense for the features, getting a sense for the data. Let's talk about actual model selection. How do you go about selecting a good model, or you just try them all? Or is there, like when you look at data, do you get a sense, or do you start with simplest to most complex? What do you do?
That's a very good question. I don't think there is a silver bullet for it. At least I haven't seen any so far. Well, we do know if it comes to pictures or natural language processing, you have to go neural networks.
Yeah, because of the features are way too many.
Yeah, if you go language analysis, you probably, or most likely, you need to go recurrent neural networks.
I see.
If you, for example, there was one project where I needed to predict regression, and then I did 2 models, and they behaved about the same. And first was multiple linear regression, and the second was neural networks. But since they predict nearly same, we chosen the simplest one.
Okay.
Because what customer really wanted was what is important, in what features are important. And linear regression in this case answered much better, because neural network is actually a black box.
Yeah, I mean, you have these hidden layers with sigmoidals that nobody knows what's going on.
So always keep in mind what you really need to achieve. Yeah, you need to predict some value, but also what is important.
I see. So you need to not only, because this makes model selection more of a horse sense kind of thing, where you want to use the simplest model that does the best, depending on if you're more exploratory or predictive.
Yeah, and it's also always the Occam razor, you know, cut the crap out, keep it simple to the degree where you can keep it simple, because the more complicated is not necessarily better.
I see.
At least I think so.
So we talked briefly, but I don't feel like we talked about enough about how someone gets into this field. What are some suggestions you have? The first thing we mentioned is get a sense for math. It's not that scary. What are some other tips you have for someone that wants to enter the data science field? Well,
I actually talk about it on my session, and I talk about how to learn stuff and how to actually know what's yours. And if you want to try, I can say I'm a big fan of Andrew Ng. There is
Coursera.
I love the guy. Yeah, the Coursera guy.
I'm a fan.
He's not a Coursera guy. He's a much bigger guy. He's like a godfather. Really.
Yeah.
So take the Coursera class. If you think that something makes sense to you, if you think that's something which sounds interesting to you, try it.
Yeah.
Go maybe attend some online competitions on Kaggle if you don't land the job, or maybe you actually can come to your company and say, you know what, I want to try some machine learning, and I doubt they will say no, because everybody now wants something machine learning, and they're out of people who actually want to do it, because most of people are scared.
Right.
So take online classes, and then after Coursera, if it's something you feel like you know it everything, that means you know nothing. It's good. That's a good spot to enter. And then you probably need to refresh your statistics.
Sure.
Because without statistics, there is no way you can do feature analysis in the start. Yeah, and then just do something. I mean, really do something. Apply, try to model it. There are a lot of, like in Kaggle now, there is a really interesting competition with premier, like money to win. It's a $1 million. That's worth working for.
Yeah, I mean that's a lot. Maybe we should just go work on that right now. So let me see if I can summarize. The first thing you said is get educated. You said there's some good resources. Andrew Ang has one on Coursera. There's a really good course that I started taking. I have not finished. I need to go do it again. I know. You give me the stink eye. I need to go back. Then you said once you do that, just do something that you learned from the course. And you said two really good examples. The first was go to Kaggle. What's Kaggle? Is that a machine learning competition?
Yeah, it's a machine learning competition.
And they have problems with data that you can go play with.
Yeah, customers submit their data and say we're going to pay so much money for the best model.
Oh, so it's like you're an actual consultant.
Yeah.
But whichever model that's the best, that's the one that wins.
And the Kaggle one is now, the active one, the $1 million one, is to predict house price.
Okay.
It's a simple domain.
Yeah, it is really. It's just like a regression problem, feels like.
Yeah.
And then the second, which I think is even more intriguing and I have not heard, is just go to your employer and say, I'm interested in machine learning. Is there something you want, or I'm interested in data science. Is there a problem you want me to solve? And just find that one question and get going. Is that what you said?
Exactly.
So once you've done that, what's the future of data science? Like now that you've done those two things, where do you go from there?
It depends what you like.
Sure.
What speaks to you.
Sure.
I mean, you can go all crazy and maybe find a job in artificial intelligence,
Sure.
more like heavy artificial intelligence. You can enjoy improving the daily life, because every business right now has a problem for machine learning.
Sure.
Machine learning is not about should I use it, it's about when I use it. And actually when is like 2 years ago already.
Yeah.
So it's like just pick one. Chances it's just gonna grow exponentially. It's like we hit the spot. We started something big here. Sometimes I start thinking maybe it's too big. But Andrew Ng said that worrying about some evil artificial intelligence who's gonna take over the world is about as rational as worrying about overpopulation on Mars.
Yeah, and I saw that, because like I understand how these models work and I understand how magical they seem. Like you'll appreciate that the first machine learning algorithm I ever wrote was in MATLAB, and it was k-means clustering.
Cool.
And I remember, because I did a step thing, and I watched the graph move, and as the little marbles sort of fell into the centers of the clusters, I was like, holy cow, it's thinking. But at the same time, I was like, well, it's Euclidean distance, and it has a finite number. It's not really thinking, but it looked like it was. And so there's a sense of wonder of these things working, but at the same time, knowing how they work, the sense of wonder was still there, but not as much. These things are not that smart.
But there are some things now which are beginning to be smart.
Tell us about those.
There are some programs which make programs. So they make artificial intelligence models, they make machine learning models. Some models make another model. So it's like they're giving birth to other models. So
that's crazy.
Yeah, it sounds crazy, but it's kind of actually cool.
So just to finish up, because we have about a minute left, tell us where can people find out about you and what you do, and then maybe if you write anything, where can people go to find that?
Well, I have a blog. It's il-adan@blogspot.no or .com, and we have a machine learning meetup in Oslo. It's Oslo Machine Learning. So just come at our next meetup if you want to talk or if you want to listen. We just welcome everybody. And I have a Twitter. It's even more complicated. I need to think on branding. It's at Illumico. So yeah,
that's kind of cool. Illumico. That sounds awesome.
Yeah, I like it.
Well, thanks so much for spending some time with us. Thanks so much for watching. Coming up next, we have Barry Dorans is going to talk about security and ASP.NET Core 2.0. It's something you don't want to miss. We'll see you right after that.